Maths, you people, with Mr. Hanna for Year 11 Methods. The second power function we've got is called a truncus. And a truncus basically contains an x to the minus 2 term. In other words, that's the exact same thing as 1 over x squared using your index laws. So let's have a plot of that and see what it looks like. So here we go, I've plotted it, x minus 2 squared, and there we go. So some people like to remember this because it's called a truncus and it looks a little bit like a tree trunk. So notice that it's got some asymptotes once again. Here along the x-axis, it never quite touches that x-axis. It gets closer and closer without touching. And similar in the y-axis, it gets closer and closer, but it never actually touches that y-axis. Now, similar to the hyperbola, we can write a general form for the truncus. And the general form looks like this. Ax minus k to the power minus 2 plus h. And of course we can write that in another way if we want to, which is ax minus k squared plus h. So there we go, there's the general form. And just like everything else, all the letters represent the same things. H is a translation up, k is a translation to the right, and A is a dilation factor, or it could be a reflection. So let's do another example and just plot it to confirm what we already know about the translations and dilations. Okay, so here's a quick plot. I've done x minus 2 to the power minus 2 plus 3. So you can see that it's been shifted up 3 and to the right 2 on 2 units. Now, sometimes you're going to get questions that are not perfectly in this general form, and you have to change them to that general form. So let's do one of those. So let's have y equals 2 over minus x minus 1 squared plus 3. Okay, so the reason it's not in general form is this negative here. Now remember from the last video on hyperbolas that that minus x there, when you have that, that could be a reflection in the y-axis. But those are a bit annoying because you sort of have to do the first a graph pretending there's no negative and then do the reflection and do another graph. Option B, which I usually choose, is to rearrange this so it's in the general form here. So let's do that. So I'll have y equals 2. Now I'm going to take out a factor of negative 1 here. So I'm going to take out the negative 1 factor, and I've got the minus x minus 1 factor here. Now the squared is applying to both of that, it's applying to everything, and plus 3. Now, another one of our index laws is that this squared applies to both the minus 1 and the, oh sorry, I've done the wrong thing with my factor, they're both pluses now because I've taken out the minus 1. So the squared applies to both factors. So it applies to the minus 1, so that would be minus 1 squared. Oops, that was minus 1 squared. And it applies to the x plus 1. So that's x plus 1 squared plus 3. Now with this minus 1 squared bit, we know that minus 1 squared is just minus 1 times minus 1, which equals positive 1. So here we have 2 divided by positive 1, which is of course just 2, and then we've got our x plus 1 squared plus 3, and we can write that in the other form if we want to, x plus 1 to the minus 2 plus 3. So now this is actually fairly straightforward to graph. We can set up some axes here. Now the plus 1 means we've moved to the left 1 unit, plus 3 means we've moved up 3 units, so our 3, and this way 1. And it's not been reflected in the x-axis, so it looks like this. Now, there's a dilation of 2, so we need to show some points to make sure that the dilation's clear. So first we'll do this point here, the y-axis intercept, so that's when x is 0. Whoa. Sorry about that. So let's when x is 0, we'll find the y-intercept. 2 times 0 plus 1, so that's 1 to the power negative 2 plus 3. Now 1 to the power anything is 1, so this just gives us 2 plus 3, which gives us 5 as this axis intercept here. That's 5. Now we need to put a random point somewhere here. Oops, I forgot to label a couple of things. So that is -1, and it goes up 3. Okay, so I'm going to put in the point -2 in x and see what I get. So x is -2. So y will then be 2 times -2 plus 1 to the power of -2 plus 3. So that's y equals 2. -2 plus 1 is -1. So that's -1 to the power -2 plus 3. Now what's happening here is a bit easier to see if I write it in the other form. So let me show you what it looks like. It's 2 over -1 squared plus 3. Now, -1 squared is -1 times -1, which is, of course, 1. So, here we have y equals 2 plus 3, and that equals 5. So this point here is -2, 5. There we go. That's not particularly surprising because the truncus is symmetrical. So it's not surprising that this is 5 and that's 5 because they're both 1 unit away from -1. This one's 1 unit that way, this one is 1 unit that way. So we've got a bit of symmetry going on here. Okay, one last example. So let's suppose we have something that looks like this. Y equals, say, 9 divided by 3x minus 4 squared plus 2. Okay, so here we're not in the general form either because we've got a 3 before this x. So we have to get rid of that 3 if we want it to be in general form. So let's do that. So we'll take out the factor of a 3. So we've got x. Now here, 3 does not go evenly into 4, so we're going to end up with a fraction of 4 on 3. Now there's the squared, applies to everything, and plus 2. Okay, so now we've got 9 over 3 squared multiplied by x minus 4 on 3 squared plus 2. Now 3 squared is 9, so we've got 9 divided by 9. So let me just write this in the other form now. I think it'll be a bit clearer. We'll have 9 divided by 9, x minus 4 on 3 minus 2 plus 2. Okay, so this gives us y equals 9 divided by 9 is 1, so we'll leave that out. X minus 4 on 3 minus 2 plus 2. And we're done. And we can see that this graph is going to be shifted to the right 4/3, and it's going to be shifted up 2. So we can do a really quick sketch of that just to make it clear. This is 4 on 3, and here somewhere we'll have 2. So those are our asymptotes there. And then we put in our truncus shape. There we go. Now, just a quick note, suppose this question all along had have had a minus sign here. That would mean bring the minus sign the whole way through the problem. And so at the end here, that would be, of course, a reflection in the a reflection in the x-axis. So that one would look like this. And then, of course, we'd need to find these axis intercepts. So I just want to flag that. All the reflections, they operate exactly the same as usual as well. So there we go. That is the truncus.